All right, here's where we left off. We had if f of x is continuous on the interval a to b, then the integral from a to b of f of x dx equals capital F of x, evaluated at a and b, which we wrote as f of b minus f of a, where what was capital F of x again? Any antiderivative of little f of x. Okay, I think that's where we left off. We wrote that theorem down, and then we did some examples. So what's left in this section is there are a couple other theorems, and we'll do a couple more theorems, and then we'll do some examples. So the next theorem in this section is called the mean value theorem for integrals. We had something called the mean value theorem before, except that was a mean value theorem that involved derivatives. What did the mean value theorem say? Function had to be continuous and differentiable. Over b minus a equals f prime of x. So that theorem said that if a function was continuous and differentiable, then there had to be a place where the slope of the tangent line was exactly the same as the slope of the secant line. The tangent line and the secant line had to be parallel somewhere. All right, here's what the mean value theorem for integral says. Let f of x be continuous on a to b. It only needs to be continuous. We don't need differentiable this time. Then there exists a value c, where c is between a and b, perhaps equal, such that the integral from a to b of f of x dx equals b minus a times f of c. What does that mean? The mean value theorem for derivatives said the slope of the tangent line has to equal the slope of the secant line. What's this theorem saying? All right. Again, it's easiest to draw a picture. So we've got some function. Looks like this. Here's A, and here's B. What does the left-hand side represent in terms of this picture? What's the integral from a to b of f of x dx represent? It's the area underneath the curve. So the left-hand side says this area has to equal, what's b minus a? Well, it's not delta x. Well, it's delta x if you're only building how many rectangles? 1. It's delta x if you're only building one rectangle. And what's f at c? So c is some number in between a and b. So c f of c would be some point. And for this problem, it looks like maybe it's right around here. So what this theorem says is you can build one rectangle. Like so, where the width of the rectangle is b minus a, so that is your delta x. Your height is f of c for some number c, and what has to happen? is the same as the area underneath the curve. So, what this theorem says is, you can find the area by building exactly one rectangle. What's the hard part? Finding the C. You don't know where to build the rectangle. That's the hard part. All right, so let's come up with an example here. I agree that this point that I picked looks like the inflection point. I think that's just a happy coincidence. I don't think this value C in general is the inflection point, but we can test it here in just a minute, see if it works out. I think that's just the way I drew it. It looks that way. I didn't intend it to be that way. Okay, so we need a function. Somebody give me a nice continuous function. What's that? Sine of x. Oh, you've decided to make it interesting. Okay. And then I need an interval. 0 to pi. 0 to pi. All right, so what must happen is the integral from 0 to pi of sine x dx must equal b minus a, that's pi minus 0, times sine of c for some number c. And what we want to do is we want to find that number c that's going to work. All right, so I think what I need to do is I need to evaluate this integral on the left-hand side and then see if I can find the c number. What's the antiderivative of sine x? Negative cosine x. Very good. So this is negative cosine x, evaluated at 0 and pi, equals pi times sine of c. On the left-hand side, I plug in pi. What's the negative cosine of pi? Zero, one, negative one. Negative one? All right, let's ignore this minus sign for a minute. What's the cosine of pi? Cosine of pi is negative 1. So when I put this 1 back in, I get positive 1. So that's going to be 1 minus. Then I plug in 0. What's the cosine of 0? Cosine of 0 is 1, but then it's got a minus sign in front of it, doesn't it? So minus and a minus is going to make it a plus, isn't it? So that's 1 plus 1 equals pi sine of c. Sine of c, therefore, has to equal 2 over pi. So c is, how do you get c all by itself? Sine inverse of 2 over pi. Anybody happen to know what the sine inverse of 2 over pi is? Nope. That would be the sine inverse of pi over 2, perhaps. Pi over 2 would be 90 degrees. Unfortunately, this is sine inverse of 2 over pi, not sine inverse of pi over 2. Sine inverse of pi over 2 is a number I could give you. It's what?
0.6901 and some other numbers.
Yeah, unfortunately, it's not a nice angle that we know. So, your two choices here are you leave it as sine inverse of 2 over pi, or you grab your calculator, you make sure your calculator is in radians mode, and you do sine inverse of 2 over pi. It's approximately 0.6901. That's the best we can do. That's what happens when you pick a function like sine. You don't always get nice answers. That's okay. Not a problem. Questions on that? Graph what?
This,
Oh, sure.
so we can see the little box.
So we're going to graph sine x. And then we're going to graph sine of sine inverse of 2 over pi. That's just 2 over pi. Let's see, my window, I want to go from 0 to pi. And make my y's go negative 2 to 2. So there's the graph of sine. And there would be our one rectangle. So, does it look like this one rectangle would have the same area as what's underneath that sine curve? It looks like it's going to be awful close, doesn't it? Because we've got a little too much area on each end. On the other hand, we're missing a little bit right there in the middle. So what must be happening is this area on the ends must add up to be the same amount as that area in the middle, and it must cancel each other out. So it definitely looks believable. Can I find that out for sure? I suppose I can. How could I find that out for sure? Well, I know the integral from 0 to pi of sine x dx is 2, right? I figured that out in this problem. And then b minus a times sine of c would be pi minus 0 times the sine of the sine inverse of 2 over pi. But what's the sine of the sine inverse of 2 over pi? It was 2 over pi times pi. 2. The pi's cancel. So it certainly does work. We found the right answer. Questions on that one? All right, let's try one more of those. How about f of x is... Let's see if we can make life a little easier this time. Give me a quadratic function. Anybody got a quadratic function they like? 4x squared plus 3. And our interval is going to be 5 to 10. All right, so this time what should happen? The integral from 5 to 10 of 4x squared plus 3 dx should be the same as 10 minus 5 times 4c squared plus 3 for some number c. What's the antiderivative of 4x squared plus 3? Four thirds x cubed plus 3x. And then I'm going to have to plug in 10, plug in 5, subtract my answers. That's 5 times 4c squared plus 3. Ten and 5. Who picked 10 and 5? Because we're going to have 4 thirds times 1,000 plus 30 minus 4 thirds times 125 plus 15. And that has to equal, I'm just going to write this as 20c squared plus 15. All right, I think it's time to use my calculator. 4 thirds times 1,000 plus 30 minus 4 thirds times 125 plus 15. My calculator says that's 1181.6 bar. Unfortunately, it will not convert that to a decimal for me. That's unfortunate. or it won't convert it to a fraction, I mean, equals 20c squared plus 15. How do I solve that equation? Subtract 15. Divide by 20. So I have c squared is 58.3 bar. And then finally, square root. So c is plus or minus the square root of 58.3 bar, which my guess is that's not a nice number. It's not. So I guess I'll leave it as a square root of 58.3. But I wrote plus and minus, but that's not correct. Why not? Only one of them's in the interval. And this can happen. Sometimes you get multiple answers. In this case, we get multiple answers. Only one of them is in the interval 5 to 10. It's also possible that you might get multiple answers, and both of them would fall within the interval. Would that be okay? Yeah, the theorem says there has to be one. There could be more than one. So for this case, our answer would be C is the square root of 58.3, which is about 7.6.
That's the height of our one rectangle.
No, this is not the height of the one rectangle. The height of the rectangle would be take this number and plug it back into your function. So this tells you where to build the rectangle. Build the rectangle here, plug it in there, and that would give you the height of the one rectangle. Other questions? Next theorem. I don't know that that's the right name, but I'm going to call it the average value theorem. How do you find average? So if, for example, if you have 5 test scores, to find the average of your test scores, you would add the 5 exams and then divide by 5. What's that? How do you find the average if you have an infinite number of numbers?
Well, I guess you're dividing by
The limit,
the
which
first,
is
yeah.
all of them added up, divided by the number.
Okay, so you would take the limit of all the numbers added up. We have a symbol for the limit of all the numbers added up. That's the integral. And then divide by, what do you divide by? Not n.
The number of ends,
Close. All right, so
right?
the average value of f of x on the interval a to b, assuming f of x is a continuous function, is 1 over b minus a times the integral from a to b of f of x dx. Why in all of these theorems do I need f of x to be continuous? Maybe. I might end up dividing by 0.
Is a discontinuity really throw your graph off?
A discontinuity could make it so that this integral had infinite area, and that would be no good, right? Then we couldn't talk about it. So as long as f of x is continuous, you're guaranteed that this integral is a number. It's not infinity. All right, so, example. Determine the average value of f of x equals, somebody give me a nice continuous function. X squared plus 2 on, what's your interval? 2 to 2? I was going to say 2 to 2 would be very easy. 2 to 2, I wouldn't have to do any work. The answer would be 0. The answer would be 0. All right, well, according to this theorem that we have, the average value is 1 over 2 minus negative 2, 1 over b minus a, times the integral from negative 2 to 2 of x squared plus 2 dx. That's 1/4 times, what's the antiderivative of x squared plus 2? 1/3 x cubed plus 2x. So that's going to be 1/4 times, I plug in the number 2. When I plug in 2, I get 8/3 plus 4. Minus, I get negative 8/3 minus 4. So that's 1/4 times, let's see, I've got 8/3 plus 8/3. What's 8/3 plus 8/3? How much? 16/3 plus 8. 4 minus negative 4 is 8. So that's going to be, I'm going to distribute the 1/4 through now. If I distribute the 1/4 through, that's 4/3 plus 2. So that's 10/3. All right, so what's that saying? Y equals x squared plus 2. And we want to go from negative 2 to 2. All right, so look at that graph and kind of estimate, think of all the values here. Where's kind of the average height of this graph? It's kind of somewhere in here, isn't it? Kind of halfway in between the high spot and the low spot, sort of. Somewhere in here. Does that look like it's about 10/3? Scaling goes 1, 2, 3, 4, 5. Yeah, so 10/3 would be 3 1/3, kind of up in there somewhere. Yeah, that looks like it's about the average. It looks like it's about halfway up the graph. Okay, so that's all that does. It finds you the average value. Questions on that one?
So, if we know how to find the exact value, I want to find it.
What do you mean you can find the exact value?
Or the exact area.
Well, we found the exact area. The exact area would be 40 over 3 would be the exact area. Why would you want the average? In what kind of situation might you want the average of something? Well, let's say this function represents cost versus demand. You might want to know the average cost of your product. Something along those lines. And that's what this would tell you. Tell you the average cost or the average price or something along those lines. Other questions? All right, our last theorem in this section. Last theorem in this section is called the fundamental theorem of calculus. Part 2. Part 1 just wasn't enough. It's like the sequel. All right, this one looks strange. It says, let f of x be the integral from a to x of f of t dt. All right, so that's a weird way to define a function. How have we defined that function? What is that? Well, let me write down the rest of the theorem, and then we'll get to it. Then, f prime of x equals little f at x. Capital F prime equals little f. Okay, so we might have a function like this. F of x, capital F of x, is defined to be the integral from 0 to x of 2t plus 1 dt. So here's what that means. What does the graph of 2t plus 1 look like? It's going to be a line. Y-intercept is 1, slope is 2. So it's that line. So in this function, f at 2 would be the integral from 0 to 2 of 2t plus 1 dt. What does this symbol mean, the integral from 0 to 2 of 2t plus 1 dt? What does that have to do with this picture? What's that?
But it's 2t plus 1, but the antiderivative of big F is f of 2.
So notice f of x. So my x is here, my x is here. So if I plug 2 into this function, it means I plug 2 in right there. You know, like this. It's not that hard. You'll see in a second. What does this mean? Forget about all this other stuff. If I just gave you that symbol, what does the integral from 0 to 2 of that function mean to do? It means the area. So what this symbol would mean was you go over here to x equals 2. So that's what f of 2 is. F of 2 simply means find that area. What would f at 5 mean to do? It would mean find the area from 0 to 5. So 5 would be over here somewhere. So f of 5 would be that area. So this kind of function, this is a strange definition. It's a strange definition to put your variable up here on the top of an integral. But what this is called an area function. For no matter what number you plug in for x, what you're doing is you're finding the area underneath that curve. Okay? Kind of a weird function. And we will not use these in this class very much at all. You'll see a lot of these if you ever take a upper level probability and statistics class. Because in probability and statistics, area and probability are the same thing. And you'll see that a lot. So you'll see a lot of integrals defined that way in probability and statistics classes. If you are a math major and you take a class like advanced calculus, you'll see lots of functions defined that way. All right, but what this fundamental theorem of calculus tells me is I want to take the derivative. So if f of x is the integral from 0 to x of 2t plus 1 dt, then what's the derivative? According to the theorem, the derivative f prime of x is little f of x. So what would little f of x be? Not 2t plus 1, 2x plus 1. Our function in this function is f. Our variable in this function is x. All right, so what's this say in words? This says in words, f of x is defined as a, what's a word you would use for this? Area. What's another word you would use for this? Integral. What's another word you would use for this? How about antiderivative? F of x is defined as an antiderivative. What happens when you take the derivative of an antiderivative? You get the original function back. This part of the theorem basically says antiderivatives and derivatives are opposites of each other. But we already knew that. Isn't that how we defined antiderivative? Didn't we find antiderivative as the function whose derivative is the original function? Yeah. All right, so these are simple problems. You hope you get a lot of these on the test. G of x is the integral from 8 to x of the cube root of t squared minus 9t dt. I want to know g prime at x. You're going to tell me g prime at x is cube root of x squared minus 9x. And that's it. You're done. You will probably not see a lot of those on the test. No.
I said you will see a lot of
No, you will see one like this on the test, but probably not a lot of them. Only one. Here's what a lot of people will do on the test. They'll make this problem much, much harder. How could you make this problem much, much harder? What they will do is they will try to take the antiderivative. All right? You can't do it for that one. But just for example, let's go back to this f of x. F of x is the integral from 0 to x of 2t plus 1 dt. And I'm going to ask you, find the derivative. What a lot of people will do, they'll do something that's fine. They'll take the antiderivative. What's the antiderivative of 2t plus 1? T squared plus t. And then I got to plug in my numbers. I got to plug in 0 and I got to plug in x. So that's x squared plus x. And then I want to find the derivative of that thing. What's the derivative of x squared plus x? 2x plus 1. A lot of work to get the right answer, correct? G of x equals the antiderivative from 8 to x of the square root, a cube root of t squared minus 9t dt. How do you find the antiderivative of the cube root of t squared minus 9t? I don't want to. I'm not even sure I can. So this problem could not be done the same way I did that first problem. Because I don't know that I have a method for finding the antiderivative of that function. I have some ideas of some things that might work, but I'd have to write them down and try them. You wouldn't have any ideas. Because you would definitely need to have at least Calc 2 to be able to answer this question. But the good news is, I can find the derivative, which is the question the teacher's going to ask on the test. The derivative is that. Questions on anything?